This is my first video about AI applications. What a better topic to start with than with recommendation systems. Almost everybody on the internet is interacting with them, whether it's YouTube or Netflix recommending the next video or Spotify suggesting music. It's a very useful tool for companies to tailor user experiences. For this project, I've extracted some data from Steam to make a game recommendation system. I will first show you the end result that people who only are interested in actually using it can already just hop on over and go and do that. And for the people who actually want to know actually how it works, you can stay for the second part. So let's hop over to the demo. So this is my website and the article. You can already click right over here to go directly to the demo. And by the way, I actually have two demos, so one actually up here and one over there. I will first show you this. So this is like an interactive thing. Here you can actually see all the games. If you also like hover over the points. So yeah, what you can do, you can type something. So maybe you want to, let's say, zoom in on some certain part. So here, for example, I can say, well, let's go for maybe like Factorio. So I'm mainly going to actually use games which I actually know. So yeah, I clicked it over here. So now I have those two games. I can do highlight and you can see that they are in this section over here. So now I can also zoom in. So this is what's it? Magnifying glass, and you can just do it like that, and you can hop on over here. I can also like add some other games. I think also like Oxygen not included. It's also somewhere near here, over there. And you can also see like other games. So Timberborn, I also know that this is also very similar. This one it's also very similar. I've never played this one, but it's also quite similar. So as you can see, it actually kind of already works, right? So similar games are kind of close to each other. One thing which is maybe also good to keep in mind is that games that are closer together are, of course, are more similar. However, it doesn't really mean that, let's say, distance over here from here to there is the same, let's say, as distance from here over there. So distances become, let's say, kind of like meaningless when you start to zoom out. So let's also try some other combinations. So this is, let's say, those kind of games, but maybe you're more into maybe, let's go for Bioshock, for example. And let's also do Bioshock over here, remastered, and Bioshock. Let's go for all the Bioshock games. I think also like, what's the game? Prey is also kind of similar-ish. So you can also like highlight those. And you can see that indeed all those games are very close. I'm not very surprised because I already tested it, of course, before I did this video. But you can see that those games are also like quite close to each other. So if you like those games, you can also see over here. And maybe if you want to do maybe play something similar, you can also like check over here, like, oh, hey, maybe those games are kind of similar-ish. Although the data I'm actually using is not that big. So sometimes you see some like weird stuff. For example, I saw also like Trine 2. I would not really say that Trine is kind of like comparable to those, but what I'm actually using is collaborative filtering. This means that the games which are close together are actually games that are played by the same people. So maybe actually people who play those games are very likely to play Trine 2, even though it's kind of like a quite different game, right? So yeah, there are most definitely some quirks in the data or the demo. Let's also maybe go somewhere else, like a horror game like Soma. Let's zoom out and let's zoom back in over here. And let's check. So Soma, it's a horror game. And you can see that apparently it's kind of like close. Now here you can see the Resident Evil games. You can also like really understand because it's also like horror-ish, I would say. And there are also like other horror games apparently. Also I think some non-horror games, but more like thriller games. But apparently they're played by the kind of like the same people. So yeah, that's like one visualization. I think it's really nice. It looks really cool. Like I said before, it can be way, way, way better if I have way more users because my data is like very limited. So yeah, I get some weird stuff. I also did it another way where I just type in some games and we'll just recommend it. So let's insert some games. So maybe let's first maybe start with, let's say, Satisfactory or something. Satisfactory. And I think we'll also like Factorio will probably hop on over somewhere. Factorio. I can't really find it. Oh, here it is. Factorio, Oxygen not included. Very logical. That's also over there, like that. And you can see that's the also recommendations. So this is also like a really cool way to check recommendations. You can also like increase the number. So you can go to 10 or like 30, whatever. And you can see bigger recommendations. So yeah, insert some games you like and see what this tool will say, which games are kind of like similar-ish or at least played by similar people. So how does it actually work? Let's start with a bit of background. There are two main types of recommendation systems, collaborative filtering and content-based filtering. In collaborative filtering, you recommend items based on what similar people liked. For example, if you enjoyed Satisfactory and Oxygen Not Included, and other people who like those games also played Factorio, there's quite a likely chance that you also like Factorio. You can do this based on different metrics. For example, purchases or ratings, for example, like dislike, likes, or stars. Also engagement or subscriptions. For this project, I use playtime because I think it's a very reliable metric. If someone enjoys a game, then it's very likely that that person will keep on playing this game, and vice versa. One big downside of collaborative filtering is that it only works after people have played the game. So let's say you have a new game which nobody has interacted with yet, then it's impossible to actually make recommendations. This is also known as the cold start problem. On the other hand, you also have content-based filtering. This technique recommends games based on properties. For example, maybe you like sci-fi games and building games. Then it's also quite likely that you will also like another sci-fi building game. In practice, most real-world recommendation systems are a combination of both. And because there are actually quite a lot of different factors going on, the systems are also quite a bit more complicated than I will just explain in this article. So here is how my system works. I started first with pre-processing the data. First I cleaned it up. So I removed games which were rarely played, and also I removed players who barely played any games. Another issue I tackled of the raw data is that I think playtime itself is not a very good or reliable metric on its own. Because let's say, for example, you play maybe Portal for 10 hours and just complete it and you really loved it. However, maybe some other teenager who has way more time on his hands played this game like 10 times to get all the achievements. I wouldn't really say that the other person who played it 10 times more likes it 10 times more. Maybe it likes it a bit more, but not like say 10 times. So instead, what I did, I applied the natural logarithm to, let's say, make the scale not linear, but logarithmic. So now if someone plays the game 10 times more, it will only increase the value by 2 points instead of like doubling like the score by 10. Then there's also another issue, which is popular versus more, let's say, niche games. For example, you have games like CSGO and Half-Life, which are played by tons of people. However, you have also a few other games, which are a bit more niche, which are maybe only played by, let's say, 2,000 or let's say 10,000 people. And those people maybe don't really like CSGO and Half-Life. So what you don't really want is those popular games just to be recommended to everybody. So what I did, I also added a penalty to the more popular games. So how did I do that? I used the inverse frequency. So you have TF, IDF, but I actually did not do the frequency part. I only did the inverse frequency part. So now if a game is just played by a handful of people, this game will, let's say, also get a higher value compared to a bit more popular games. I also experimented with other pre-processing steps, like one thing which I thought would also be an issue, that some games are just played for longer than other games. For example, like Portal, you play, let's say, for 10 hours and you can finish the game. But other games, let's say, you play maybe like an MMORPG, or maybe you play, let's say, CSGO, then you maybe play it for like, let's say, 1,000 hours or something. That's not even that really weird. So some games just take longer than other games. So I also wanted to scale for those kind of things. However, I found that recommendations were actually kind of like weird, I would say. So I actually removed this step. Once the data was pre-processed, I could finally create 2 cool demos. The first demo I created was the 2D plot, which I created using UMap. Explaining how UMap works is kind of like out of the scope of this article, so I would not do that. But it's basically a dimension reduction method which places samples, or in this case items, close together, which are more similar. The second demo actually required 2 steps, because I wanted to just like recommend games to people. However, it doesn't really work quite well to just recommend games which are played by similar people. For example, let's say you like a game which is only played, let's say, by 4 different people, but those 4 people, maybe 2 out of those 4, have completely different tastes than yours. And because the data is so sparse, you get a lot of recommendations which those 2 people had. So instead of comparing exactly which games you played, it's maybe better to compare which games you roughly played. So for example, maybe you played Satisfactory, but maybe someone else played Factorio, which are kind of like similar-ish games. So you don't want to look for exact matches, but you want to look for rough matches. This is a way more stable approach, and which gives you way better recommendations. For this, I use singular value decomposition, which is just like UMap, a dimension reduction method, which helps me to create, let's say, archetypes or something like that. So these are like patterns in the data, which are very typical. You can choose to create the archetypes for either the users or the items. In this case, I decided to create the archetypes for the users, such that I can represent the games in different user types. So now I can recommend games like that. So I can just say like, oh, this game is played by this kind of people, and this game is also played by kind of like similar-ish people. So probably these two games are liked by the same people. So once those archetypes are made, I can finally make recommendations. So now I can say like which 5 or 10 games are the most similar in those, let's say, archetype user space compared to other games. So let's say I can just say, okay, these 5 are the closest. However, I did a small twist. I also like to add different games. So now you can also not only select 1 or 2 or 3 games. So in this case, I actually create an average archetype, let's say. So it will just like combine all those 3 games in one, let's say, fictional game. And we'll say like which other games are similar to this average game. So yeah, that's about it. That's how the algorithm works. I hope it was clear. I will probably turn this project in an exercise of my machine learning course I'm working at. And if you liked it, you can like the video, or you can also place a comment in the comment section, because I think also the recommendation system of YouTube also really likes that. And of course, you can also subscribe to the channel to make the number go up, even though YouTube doesn't really care about this number at all for making recommendations, but it's still cool to see the number going up. See ya!